Hey everyone, today we're going to explore the three categories of AI agents, what different use cases they serve, and when it's most appropriate to use each pattern. First, we'll go through the basics. What is an agent? What are the different types of agents? And when would we want to use agent designs rather than traditional procedural ones? Then, to illustrate the concepts, we'll dive into the Azure AI Foundry agent framework to see how we can use agent framework to implement each type of agent in code. First, let's define what an agent is, see how LLMs make them powerful, and think about why we would want to use an agent in the first place. An agent is an intelligent software entity that can understand goals, plan actions, and use tools to accomplish those goals. What sets an agent apart from a simple chatbot or assistant is autonomy. Assistants respond to you, they wait for input. Agents act on your behalf. They can plan, reason, and use external tools like databases, APIs, or document stores to get things done. As with many agent frameworks, in Azure AI Foundry, every agent is powered by an LLM, the reasoning engine that helps it decide what to do next. Think of an agent architecture as having two layers. LLMs provide the reasoning, tools provide the ability to act. We can think about agents following three distinct patterns. First are chat-based assistants, which follow an interactive chat response pattern. These assistants are designed to use language or multimodal models to provide information to users in real time. Some would argue that chat assistants aren't really agents because they only operate in the presence of a human operator and follow user instructions, but chat assistants often do integrate tools, agent to agent calls, and RAG patterns, and can even have some degree of freedom in how these tools are used. So I'm including them as the first agentic pattern. Second are workflow agents, which are focused on processing some input data or signal to produce some output or action. They're called workflow agents because they follow a predefined set of steps arranged as a graph. Each node in the graph is typically another agent or tool, and while the path the workflow agent follows may have conditional branching logic, workflow agents are primarily created to follow a defined process to produce some output data or achieve some goal. And the third are autonomous agents. These agents are also composed of other agents and tools, but they have more freedom to choose which tools are appropriate to reach a given goal and in what order to use the agents and tools at its disposal. The key difference between the three agentic patterns is the degree of freedom an agent has in leveraging tools and calling on other agents. Let's dive deeper into each agent pattern and look at a code sample to understand how each might be implemented. We'll use Microsoft Agent Framework in these examples, but certainly the same concepts can be implemented in other frameworks, or even raw code if you want to build an AI agent system from the ground up. So first, chat agents. These are the ones that most people think of. An LLM that holds a conversation, answers questions, and may use retrieval to ground responses and facts. Think of a customer support bot that can look up product details or policy documents using RAG behind the scenes to provide accurate, up-to-date answers. Let's take a look at some code. Here's a chat agent that implements a simple chatbot using Microsoft Agentic Framework's AI project client. To create the agent, we call the create agent method, passing in the name of the model deployment, and in this case, I'm using OpenAI's GPT-5 Mini. It's deployed in Azure AI Foundry. Then we create a thread, which provides short-term memory to the agent, so it has access to previous prompts and responses each time it responds to a new prompt. Then we'll just create a loop that allows the agent to respond to user prompts until we hit the enter key without providing any further questions. The result is a simple chatbot, but it's powerful. It uses a high-quality LLM deployed in the cloud to handle responses, and it maintains short-term memory for context with virtually no effort on our part as the developer. We could extend this agent with tools such as RAG agents, web searching, or database queries to ground responses, but let's get to the next pattern to add that complexity. Workflow agents follow a predefined graph of steps or tasks, sometimes with branching logic depending on input data or intermediate results. This type of agent doesn't depend on a user at the keyboard. Often a workflow agent is triggered by some new data or state change in another system. Think about an agent that runs when a new file is uploaded to a storage account. For example, an invoice processing agent might extract text from a document, classify it by type, validate totals, and route it differently if it's missing information. So each step is typically an agent that calls its own tools to accomplish this task. Azure AI Foundry supports this pattern through the workflow graph objects in the agent framework, and this is sometimes just referred to as multi-agent workflows. So these workflow agents give us consistency and control. They're predictable, auditable, and perfect for enterprise automation scenarios. So let's look at some code to see how a workflow agent is built. This time, I'm not going to run the workflow. I just want to give you an idea of how a workflow is designed. In this example, we'll implement a workflow agent that reads a job applicant resume. It uses a tool to extract it into plain text, and we'll use Azure Document Intelligence as an external service from within the tool. Then once the resume is cracked into text, we'll use another tool to analyze the resume and summarize key experiences and skills the candidate presented in the resume. We'll start by creating an Azure AI agent client, which will help us create each agent that we'll use as a graph node in the workflow. Then we'll create two agents. First, a PDF reader agent, which will be responsible for reading resumes received in PDF format. And second, a resume reviewer agent, which will take the output of the PDF reader agent and perform the summarization process. This is just a quick example, but in a production system, we would probably have other agents. For example, agents that store the summaries and source documents in a recruiting system, or agents that email hiring managers when a resume meets some defined set of characteristics. So to run the workflow, we'll use the agent framework workflow builder object and add each agent to the graph. Then we'll use the run stream method to start the workflow. So as the workflow executes, we'll receive updates, and when the entire workflow is finished, we'll receive the final response in event.data. So the key takeaway here is that we defined agents that each have a specific job. We organized them as a workflow graph, and then we kicked off the workflow that runs the edges in the graph. Finally, we have autonomous agents. This is the most advanced type. These agents are given a goal, not just a task list. So they can decide how they accomplish the goal, choosing which tools to use, in what order, and even creating plans on the fly. So a simple example would be like a research assistant agent. You might tell it, prepare a competitor analysis report. It decides to search the web, retrieve financial data, summarize articles, and assemble the report automatically. If we ask the research agent to research stock market performance, it might use a tool that fetched market and economic data. On the other hand, if we asked it to research Renaissance poetry, it might use a connection to a public library API instead. The key for these agents is that they have tools to cover a variety of needs, and they'll decide which to use and in which order. Quite different than a workflow agent where the agent's task is predefined. You saw the workflow agent implemented in code, so let's see how the code is different for an autonomous agent. In this example, we'll implement an autonomous agent to process invoices. The agent will read the invoices, check whether invoices align with purchase orders, and if so, post them to the ERP system so they're scheduled for payment. Let's see one way to implement an autonomous agent using the Microsoft Agent Framework. So as before, we'll create an object for each agent, the same as with the workflow agent. In this case, we'll create worker agents for extracting invoices from PDFs, validating them against purchase orders, and posting invoices for payment. An agent we didn't create in the workflow pattern is the orchestrator. A graph doesn't need an orchestrator agent because the workflow path is predefined. In an autonomous agent, the orchestrator will decide at runtime what path the work should follow. Now, if I scroll up here, you can see that each task agent is basically a prompt which tells the agent what its purpose is. Then we give each task agent a tool, which is the code it will use to accomplish its purpose. For example, if we scroll up to the Extract Invoice tool, we can see that it uses Azure Document Intelligence to extract an invoice. This is similar to the previous workflow agent example. Returning to the main flow, notice that each of the agents is added to the AI agent client as it's created. All of the task agents are visible to the orchestrator, but this time without any specific instructions about when each agent should be used to reach the goal. Next, we'll send a message to the agent client with the goal in the content field. This tells the agent service what we want to accomplish. Since the goal aligns with the orchestrator, that agent will be run first. The orchestrator's instructions will tell it to call tools to accomplish the goal, but we don't specifically tell the orchestrator which tools it should call or in what order. It's the orchestrator's job to decide how to accomplish the goal. Then, to run the agentic system, we put the system in a loop, first running the orchestrator, letting it think about what to do next. The orchestrator will respond by telling the control loop which tool to run next. The orchestrator can ask for any tool, or even ask for the same tool to be run more than once. We have a trap that once the orchestrator calls the ERP post tool, the process is complete, and we can clean up the resources and exit. So this example was pretty simple, and yeah, we could probably just have used a workflow tool instead, but think about how flexible this is and how much more this agent could do. For example, we could add more agents that handle different types or formats of documents. We could add a translation tool and a currency conversion tool that the orchestrator called when needed. That much variability might be possible in a workflow agent, but it would be more complex to design and difficult to maintain. So to wrap up, agents represent the next step in how we use LLMs to build intelligent, goal-oriented systems. We looked at how chat agents provide conversation, how workflow agents deliver structured automation, and how autonomous agents bring adaptive intelligence. If you'd like to learn more about designing agentic AI agents, check out the links below, and I'll see you next time.